Hi everyone, this is MK and this is another LeetCode daily challenge. But before I start a question, do you know what Fermi paradox is? Fermi paradox questions why, given the vastness of the universe and the high probability of alien civilizations existing, no concrete evidence of extraterrestrial life has been found. And it highlights the contradiction between the likelihood of such civilizations and the lack of contact or observable signs of their existence. Read more about this paradox. It's nice and beautiful, especially this chain of reasoning on this Wikipedia page. Let's go and talk about the question. So this week's questions are about linked lists, as you can say if you have solved the last few problems of the last few days. This one is no different. This is kind of the combination of the questions of the past 2 or 3 days. So we are given a linked list, the head of a singly linked list, which is L0, L1 up to Ln, and we should reorder that into L0, Ln, L1, Ln minus 1, L2, and so on. We should modify the nodes in place. We cannot change them. We just need to change the links between the nodes. So let's take a look here. We have 1, 2, 3, 4. It should become 1, 4, 2, 3. 1, 4, 2, 3. Okay. Here we have 1, 2, 3, 4, 5. It should become 1, 5, 2, 3, and 1, 5, 2, 4, and 3. So if we look at it here, so we have 1, 2, 3, and 4. This is the first example. So what if you notice, this is going to become 1 and 2, and here we have 4 and we have 3. So if you look at the order, so 1 and 2 are the first half of the linked list, and 4 and 3 are the second half of the linked list, but in reversed order. That's why I say this is a combination of the problems of the last few days. So what we need to do is we need to let's take a look at the other example first. So this is 1. If we reorder them, it's going to be 1, 5, 1, 5, 2, 4, and 3. Again, if we look at the order of them, it's going to be 1, 2, 3. This is the first half. And we have 5 and 4. This is the second half, but in reverse order. Okay, so what we need to do is we need to find the middle of the linked list and reverse the second part. So in order to find the middle of the linked list, there is some technique in linked list that is with a slow pointer and fast pointer. And what that does is that if the slow pointer goes 1 step at a time and the fast pointer goes 2 steps at a time, by the time fast is at the end of the linked list, a slow is pointing to the middle of the linked list. Let's have a look. So we have 1, 2, 3, 4. I'm not going to draw the links here. So if a slow is here, fast is here. A slow goes 1 step, a slow is here, fast goes 2 steps. So fast is here. So because at this point, because fast.next doesn't exist, so we stop here. So in this stage, slow.next points to the rest of the slow.next points to the rest of the linked list, which is the second half. So we are looking for slow.next. So this is with 4 nodes. If we have 5 nodes, let's take a look at 5 nodes. We have 1, 2, 3, 4, and 5. And we have 2 pointers. We have slow and fast. The slow goes 1 step, fast goes 2 steps. The slow goes 1 step and this is a slow, this is a slow. Okay. The slow goes 1 step, fast goes 2 steps. Okay, and at this point, again, slow.next is the second half of the linked list. So again, we are looking for slow.next. We just need to check for fast.next and fast.next. While this exists, slow goes one step, fast goes two steps, and when we stop, okay, as slow.next is the middle of the is the head of the second half. So okay, all right. So we have the middle of the linked list. That's good. We have the middle of the linked list. That's good. So now we need to reverse the second half. We need to reverse the second half. So let's go and write the code part one by one. I think we're going to forget if I explain all of it and then I start coding. Let's go and do the first part. The first part is I'm going to do TypeScript for now. I used to do C++. I started doing TypeScript. So we have let's slow. So first, the base case is if head is null or head.next is null, that means like we have one node, or we have two nodes. Head.next.next is null. We just return. We don't do anything in that case, right? If we have 0 nodes, 1 nodes, or 2 nodes, we don't do anything. So here we have let slow equals head, let fast equals head, and while fast.next and fast.next.next, what happens here is that slow equals slow.next, one step, remember, and fast goes 2 steps, fast.next.next. Okay, and now here we know that slow is pointing, slow.next is pointing to the second half of the linked list. Okay, so we have this. Now we should reverse the second half. Let's see how we can reverse that. Let's go back to the whiteboard. Here we have, let's say we have 1, 2, and 3, and we want to reverse that. What do? Is we start by 2 pointers. One of them is pointing to the actual linked list. We call that, let's say, forward. I don't know. Yeah. And we start, the other pointer should be null. This is previous. I call this previous and I call the other one forward. So what should happen is that 1 should point to null. And when 1 points to null, which is the head of the previous, the head of the reversed linked list, okay, then forward goes 1 step forward. So we delete this link. Forward now is pointing here. So this is forward. And previous is now pointing here. So previous is not here anymore. So previous is here. That's it. So we should do this. Just that. Let's go and write this part of the code. And we keep doing that. What we need to do, let's look at here. So forward.next should be kept somewhere. So I'm just going to write the code here. So temp becomes forward.next. So I memorize, I keep track of who forward is pointing to, okay? Then I tell forward, hey forward, would you please now point to previous? Because there should be some link here. So then I say, hey, forward.next should become previous. All right, that's good. Now forward should go and point to this temp actually, right? So forward Oh, sorry. Before that. So we got rid of this. So this is not here anymore. Before that, previous should come and become forward. So previous becomes forward. That means now previous is pointing to 2, right? And then forward should become temp. So the order of these 4 statements are very important. Let's go back and write a function that does the reverse for us. So I'm gonna call this let reverse, and I'm gonna write a function that does that for me. Reverse slow.next. Okay, so here function reverse. I have some list node which is called forward list node, and I'm gonna return list node. Okay, so this is input, this is output if you haven't done TypeScript before. So here what we need to do is we need let's prev, we need to define some previous. If you remember, it's going to be list node or null, and we initialize that to be null. And then we start our journey, our while loop, not a journey. So while forward, what happens is that let temp equals forward.next. So we keep the link of forward.next somewhere. Then we say, hey, forward, now your next is prev. Okay, then prev becomes forward, and then temp forward becomes temp. That's it. And then we return. What do we return here? We just return prev. Yeah, we return prev, which is the head of the reversed linked list. So now we have the rev. Something to remember is that we need to get rid of the link in between the first part and the second part. Let's go and look at it here. So yeah, this one. So remember a slow was, where's a slow? Yeah, here. Remember a slow is pointing to 2. A slow.next is the beginning of the second part of the linked list, right? So we should say, hey, 2, you don't have a next anymore. Sorry, you don't have a next anymore. So we say s.next equals to null. That's how we break the link between the first part and the second part. So here we say slow.next equals null. All right. Here comes the last part, merging, or yeah, I think, yeah, that is merging 2 parts, which are head, namely head and rev. So we should merge head and rev. Let's go and take a look at how we can do this. So here, let's say head is now 1, 2, 3, right? And rev, this is head. And rev is actually 5 and 4. So what should happen is we should go to 1 and say, hey, 1, your link is going to change. Now you're going to point to 5. And then we are going to tell 5, hey, 5, you're going to now point to 2. All right. So this is what happened. So we get rid of this link. We get rid of this link. Okay. But we know, and we move both of them 1 step forward. So now head is here and rev is here. Okay. Then again, we go to head and say, hey, head, you should point to 4. You know that. And then we tell 4, hey, 4, you should point to 3. And then we get rid of this link and we move both of them 1 step forward. This is head now, and this is rev. So you see, when rev is pointing to null, this is null. We don't have anything here. So when rev is pointing to null, we are done. And in order to do this, let's just go back and do it one more time. So what we need to do is when we are changing the links, we need to keep track of head.next and rev.next in some temporary variable. Change the links and then move head forward to head.temp. This is head temp. And this is rev temp. So we change the links for head and for rev, and then we say, hey head, go, and now you become head temp. And when we tell rev, and we tell rev that now you should become rev temp. Oh, okay, let's write the code here. While rev, so we need two temporary variables. So let head temp becomes temp dot next. Let rev temp becomes rev dot next. Okay, now head dot next becomes rev. Rev dot next becomes head temp, which is head dot next. Now head equals head temp, rev equals rev temp. Yeah, that's it, I think. Okay, let's see if we are doing it correctly. Okay, cannot name temp. Oh no, not temp, head. Yeah. All right, 2 green flags. Let's go and submit. That's it. So if you like my explanations, please like and subscribe if you haven't done already so. That means a lot, and see you tomorrow. Thank you.